In this video, we are going to study linearity in parameters with Ramsey reset test in Python using Jupyter Notebook. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Okay, so let's go into the web browser where the Jupyter Notebook is located. So the first thing we need to do within the video is we need to add a new cell below, and we do so by clicking on the Insert Cell Below button. Then, regarding the code, the first step is we need to import the corresponding packages. Therefore, we're going to comment this as step 1, which is packages. And first, we're going to import stats models.api as SM. We're importing that feature from stats models for data downloading. Then we're going to import stats models.formula.api as SMF. We're importing that feature from stats models for our multiple linear regression calculation. And last, we're going to import stats models.stats.diagnostic as SMD. We're importing that feature from stats models for Ramsey reset test. To run these code lines or this cell, we can either click Run or press Shift Enter on the keyboard. Then we continue with step number 2, which is data. For this, we're going to create an object named house prices underscore object, which is equal to sm feature from stats models dot datasets dot get underscore r dataset, and within parentheses we have the following parameters. The first of this, which is data name, equals to, and within quotations, house prices, comma, package equals to, and within quotations, AER, comma, cache equals to true. So what we're doing here is we are downloading house prices object from our package AER, and with cache equals to true means that when we download the data, it saves it locally, so we don't need to go and download it again every time we run the code. Notice that this would download data and documentation within house prices object. Therefore, we continue with the following code line, which is we create an object named house prices, which only includes data. Therefore, equals to house prices underscore object, and we get its .data attribute. And then we want to visualize a part of this data frame. Therefore, we do the following with the code line of print, and we open parentheses, and from the house prices object, the one that includes the data, with .iloc or integer location, we select with semicolons, meaning all the rows, comma, from columns 0 to 3, with Python notation, we're selecting the first 3 columns of data dot head so that we print the head of that data frame. Again, to run these code lines, now we directly press Shift Enter on the keyboard, and we can see the head of that corresponding data frame and part of it. So we have the first 5 rows of data of the first 3 columns of data of price, lot size, and bedrooms. And the reason we're only visualizing that data is because we're going to calculate a multiple linear regression in which the dependent or explained variable is going to be price and the independent or explanatory variables are going to be lot size and bedrooms. If you want to read the full documentation on this data, you can do so with the following code line, which is print and from the house prices underscore object, we get its dot 2 underscores doc 2 underscores attribute. And in this case, it's a single code line, so we just go ahead and press Shift Enter on the keyboard. And there you can see the full documentation for data. So now we're going to scroll down and we continue with step number 3, which is the model. For this model, we're going to create an object named MLR, which stands for multiple linear regression, equals to SMF feature from stats models dot OLS, which stands for ordinary least squares function, and within parentheses we have the following parameters. First of this, which is formula, equals to, and within quotations we have price, and with this special character means being explained by lot size plus bedrooms, comma, data, house prices object we created above, and then we fit this regression, open and close parentheses. So to run this code line or this cell, we press Shift Enter on the keyboard, and with that we calculated the model. So now we're going to continue with step number 4, which is linearity, and we are going to test linearity for the model using Ramsey reset test. Therefore, we're going to create an object named reset test, which is equal to SMD feature from stats models dot linear underscore reset function with Ramsey reset test and the following parameters. The first of this is going to be RES equals to MLR, which is the multiple linear regression we fitted above, power equals to 2, comma, test underscore type equals to, and within quotations fitted, comma, use underscore F equals to true. So what we're doing here is the following. Previously we fitted a multiple linear regression with the corresponding model, and then we're going to test linearity using Ramsey reset test, which consists of doing a new regression which has the same formula as the original one, but, and in this case as an example for educational purposes, it's going to add at the end of that regression as independent or explanatory variable the squared fitted values from the original regression. And with use F equals to true means that it's going to perform an F test. Notice that all of these parameters, specifically power 2, test type equals to fitted for fitted values, and use F for F test equals to true, were only included as educational examples, therefore they are not fixed and they can be modified according to your needs. So this Ramsey reset test, as mentioned previously, is going to perform an F test. This F test is a joint null hypothesis that the fitted values powers coefficients are equal to 0. In this specific case, we're only including square fitted values, therefore the power 2 and the test type fitted. Therefore, it's a hypothesis of one coefficient. And then we want to continue to print the results from this test. So we do so with print and within parentheses reset test. And again, to run this code lines or this cell, we press Shift Enter on the keyboard. And at the bottom, we see the results from Ramsey reset test. Specifically, we see the corresponding F statistic for the test, degrees of freedom, and the p-value. In this case, we have the Ramsey reset test p-value, in which the null hypothesis is that the squared fitted values coefficient equals to 0. In this specific case, as mentioned previously, as an educational example. If rejected, model has incorrect functional form or misspecification. If not rejected, model has correct functional form when including square fitted values in test. As mentioned previously, notice that test can include cubic and more fitted valued powers, which would depend on your specific needs. Perfect. So, now that we finished with the code, we go ahead and save it. And with this, we finish this video. Thank you for watching.